Okay, so now coming to the next point, packet switching and network models. So we will see some few new things in this today's lecture. Network interface card, what is difference between hub switches and routers, what is difference between home network, campus, internet, and then what are the TCP IP and OS reference model. So in the olden times, what is mean by circuit switching means that circuit always need to complete their path to do something. For example, when we put the switch light on, then circuit is completed. That's why it is a complete part, and we can call that the circuit switching. You know, if in the 10-15 years back we have old phones where they have a phone at home, we dial it and then try to call someone, and it's going to the exchange. They were work on the function of a circuit switching where you have a dedicated line. But if in case that dedicated line is broken, then you are totally disconnected. Okay, so in order to fix that issue, the other things comes which is known as packet switching. In packet switching, rather you are sending the data from one path, you make it in small packets and use multiple paths to reach at the destination. In that way you are able to reduce the risk, and your that connection is still established even from one path it is broken. Is it clear? Packet and circuit switching. So this is what it is explaining about. I just make a very brief introduction of that. So see, the conception of packet switching was done by two different individuals, and they have work on that thing about how that thing is working.
So what's an example of packet switching?
Packet switching, for example, if you are let's say right nowadays, every communication is done on with packet switching. Our
Like
data is,
social media messaging.
yeah, when we learn about in the future things more on, we are actually doing every single thing on different platforms, and whenever the data is going on over the internet, they are going in different packets, and at the receiving end they become then together. For example, someone is sending you a parcel from overseas in a big box, and it's a one big picture, but they know that they are in different parts, bigger and smaller. Now if they put it the way they want to put it, maybe it takes more space. They need to break in a way that and put the numbers on, then those numbers are in page, that page is there as well, where the information is written. Okay, the image number 1 should come there, image number 2 comes there, then you can see and then again assemble it again by looking that information. Okay, so that's one of the things. So now most of the things are on packet switching. Then other important thing was interface messaging processor. I think we did this last week recording. We did that. I made that recording of this. Maybe I will share with you that one, where you can see more in detail on that. Okay, but I'm just want to give you a taste so that week 3 makes sense today to you when I explain. Okay, so IMPs, these are the initial name of routers. Okay, before that, the concept of router, they are known as interface message processors. Okay, and in 1969, that was the first time they were started from there. Whatsoever the duty of the internet router is doing today, that was the name of IMP. So packet fragmentation, the example I gave you about that box, like in the packet switching, you make of small fragments, squeeze in, because let's say in one packet you are allowed to send a data of 1500 bytes. If you want to send more, then you need 3000 bytes, then you need 4500 bytes. So it means that when you squeeze in, that's a fragmentation. And then also you want to make it reassemble as well. How you reassemble? When you have that information, that which packet goes where, which I gave you the example already. Okay, packet switching, it's used everywhere in home networks, large networks, wherever we are using internet, mobile phone, telephones, everything, they are on that thing. So yeah, come forward. So any network, when it's connected, either you normally need a, if you have more than 2 species or more than that, you always need a hub. But hub is again an old technology. Now it is replaced by a switch. Switch has the capability to see, let's say on we are in one room, 10 computers are there, we put a switch, and then with switch we connect all computers with that. So switch actually give us the ability to 10 people in the room can talk to each other over a computer. And then when you are putting the things on this switch and you're communicating, those ports numbers are there, which you know that okay, if I want to send a message to uh, computer A to C, so by typing it, it knows that where to send that message. So they are known as a smart switches. So this is how you can see that their switches RJ45 cables goes in and how it looks like. Routers, unlike PCs and servers, they have only one network interface card. Network interface card is the thing which is connected. For example, right now this thing in there, that's where it is interface where you connect it to connect to internet. Our laptops, our Wi-Fi devices, Wi-Fi device itself is having a network interface card, which actually do that job for us. Whereas in routers, they have minimum two network interface card. How many? Two, not less than two, always two. Because one is, this router is for the inner world and one is connected for the outer world. So you can see one interface card here, one interface card here. This is a switch and this is computers. So they have IP address, they have IP address, they have, wherever there is a network interface card, they have IP address. Okay, so this is how now we can say that how many different networks are there in this figure? Three. One, this itself is a network as well, network of routers. Make sense? Okay. So coming to the home networks, what are the home networks things? PC, tablets, printers, internet, TV. These are all different devices we can use at home, and that's also use IP addresses, and they are connected with each other. And what is the advantages of Wi-Fi? Okay, what is the Wi-Fi stands for? Wireless fidelity. What is fidelity means? Reliability. Okay, how much reliable Wi-Fi is? See, if the connection is wired, there is no question of reliability, because we can see that those are connected. Whenever it is in Wi-Fi, then it becomes a question of reliability. Is it that the message over the wireless is reaching at the destination or not? Yes, because in the Wi-Fi environment you are not sure yet, but in the wired environment you are 100% sure. So that's why Wi-Fi has more now in use. They have a simple connectivity. The data is encrypted, means like no one can decode it. It's go in the form of encryption form. Low power transmission. Low power transmission mean our networks, internet, the field of networking is on very low power. On the other hand, the power used at our home in the cities to put the light on, they are on high power, less frequency. Whereas for networks, computers, mobile phones, they have low power but high frequency. That's two different domains of electrical engineering. One is in power, one is in communication. Okay. So this is again for a reference of a home small network. Switch is there connected with the different devices, and they have either use it with the Wi-Fi as well. Wi-Fi can be act as a switch as well, because then with the Wi-Fi you are able to connect multiple devices. Campus network, like the way how your Federation University network, ATMC network has, they need more things into that. They need file servers separately. They need video server separately, email server separately. Database servers are separate. So a server mean separate computer, which has the capability to talk with the other things. So that network is divided into multiple subnetworks. Maybe this lab has a sub network of 10 computers, then other lab, but ATMC has one network where they have 100 of computers, then ATMC Sydney and Melbourne has the network of 500 computers. So then they have on top from where their main connection is going on. Okay. Again, please go to those video notes lectures. I will upload those one which I gave last week, and also the one I already shared. This is from the previous semester sometime. So both is good for you to, maybe you are going home and just listen to the recording. At least you know what we have explained in detail. So here you can see reference. This is a campus network looks like. If there are three different campuses, they have their own servers, own PCs, multiple things, and they are separate to each other on that. So and they have a network of multiple computers, and you can see that all of them are connected with the router. And router has always minimum 2 NICs or maybe more as well. Depends if we need from one router make it more connections. So now coming toward the world of internet, remember that each network on the internet is identified by a unique network number. The way how your mobile has a IMEI number, you know that. Similarly, for the internet, they have the same thing as well. So you know that the sender and receiver, you can identify them. If they are not, you can't identify them, then you can't communicate over the network. So you can see that they have network IDs. These are the routers, and then inside that, between that, you can judge them where they are located. You can easily see with the routers information that from where that information is coming from. So this is again the question of that eBay purchase. Like you can tell yourself how it identify that it is going to eBay server and where it is located, how many number of different jumps he need to make to reach there, how many number of PCs are required, how the payment is not compromised. So these are all the questions which are solved 10-15 years back to put this thing possible, to use an internet as a safe place, at least a bit of a safe place. Still it is not 100% safe. Okay, make it and divide and conquer. Yeah. So again, now coming to the point, now internet itself is a very big thing. There are a lot of stuff in that. The way the example of let's say doctor, you go to a doctor. As our human body, we have a nervous system, vascular system, skeletal. But if we looking as a body is one, it's very complex. But if we divide into small parts, try to solve them separately, understand it, then it makes sense to us. So it means divide and conquer analogy. Divide it, learn it, and conquer it, and then move forward. Very important this thing to understand. This example is very important for you to understand that in the field of networking, why this example is given. You can see that this is an example like how you purchase a ticket. Ticket purchase, baggage, the gates, runway, takeoff, airplane going, and then reaching at the end. Okay, this is how it works. This is in timely manner, going like that way. What's the difference between this image and this image? What do you think? What you can see the difference? Hmm? What you can see the main difference between these two images? Anyone?
It shows the destinations.
Yeah.
Like, first of all, there is like a departure airport, and then there is an arrival airport. Like routes
Mm-hmm.
between the.
Which one? That one?
No, the right one.
Okay. Okay. See, in this one, let's say we are going this way, but every department is at the same time connected with this one as well. Let's say if baggage check is something happen, you will straightforward check to this one, but at the same time you are going this way, but this information is going that way. Okay, so it means that there is something which is at the same time, because for as a human, for us, let's say one thing is going like this way, another thing is going like this way. Like one is like going like this way, you can see only what? This circle. You can't see this is a pen. For you, this is just a red dot, isn't? In front of you, it's a red circle which is going on. But for me, from here, it's like a line. You say no, this is a circle. I say no, this is a line. So basically, for a human, if two things are going like this way, for hard to imagine that how I give them equal notice at the same time. So why we are explaining that? Usually in this process, once we, this is a timely manner going on step by step, but at the same point they are connected parallelly each other as well. For example, president will meet president, prime minister, prime minister will meet prime minister, immigration minister or immigration minister of two countries. But at the same time, diplomatic relationships are going on as well to make that happen. Now, why this example is important? We are using actually a TCP model, or there are two different models which are used to explain this whole concept of networking and how we can do that. So if we go from here, see, this is an internet model which has 5 layers. In TCP IP model, we will see what is meaning of that later on. They have 5 layers: application, next one, transport, internet, network layer, network interface, and physical. Okay, these 5 layers are there, and every layer has their own job. Every layer has, like the way the ticketing thing, ticket, baggage, other things, everyone has their own job at their own layers. Okay, application, as you open computer, what you do? Always you open an application. When you open it, you Google it. As you press enter, it transport to where? On network. Once it is on network, it pass from an interface of network and go on a physical line on wires. This way it's easy to remember. Whereas in OSI model there is another thing, which is, one is TCP model, another is OSI model. OSI model, only difference is that these 3 things are taken as one in TCP. The rest is almost same. So these are the difference between OSI and TCP. So here you can see the difference. These are all same. Just these 3 are in one. So this is more in advance. This is more in use right nowadays. OSI was the initial conception of the idea of doing that thing. But right now we are actually doing more on TCP/IP. I would prefer that you should go to see this part of lecture on that video separate, definitely this part, because you need to understand it very well when move forward. So you can now see from here, data link layer and network layer. What are the data link layer and network layer? You can go back and see. Data link layer is, remember that it's always from 1 to 2, like this way. Like in the building we enter, always there is a ground floor and 1, 2, 3, 4, 5. Similarly, this is a layer 1. This is layer 5. So data link is where? Data link is layer 2. So any information which is related to whatsoever this PC is generated, hop to hop mean how the kangaroo hops, jumps. Like let's say if I am connecting to an eBay server from my computer, how many number of different router it jumps to reach there? That is known as hops. That information is only with the data link layer. This layer doesn't know. Like the way we see the example of baggage claim, and from that, they are that department, they work separately from that. So network layer doesn't know about what is hop to hop. So that's why we can see that if I want to reach at this destination, 1 hop, 2 hop, 3 hop, I'm there. But depends on, if let's say if you are just accessing any server which is located in Sydney, maybe you need to reach there in 3 hops. But if it's in USA, maybe you need 10 hops to reach there. Whereas network layer, they work host to host. They don't know about hop to hop. They know about host to host. Whatsoever the host that one has and this one, they directly can communicate. They are on a different layer of level. Make sense? And then transport layer work on application to application layer. What your application is open on the receiving end, your that application is also communicating with that at the same time. So you can see that this type of link is going on as well, and this thing is going as well. That's analogy of aeroplane at the same time. Okay, but I would definitely prefer that you should go and see those slides definitely, because these are your building block of your networking. If remember that if any brick which is just on the foundation is not perfectly put, it's little bit tilted, after 10 or months that tilt will be going toward another way and it's a complete disaster for you. So your basics, your foundation should be strong to move forward on. So that's how we are finished with the first 2 lectures, and then our next this week lecture was about application layer. Okay, now stop it this one.